In this video, I'll be working out the section 10.2 Day 2 notes. We're talking a little bit more about arithmetic sequences today, and in particular, we're looking at an arithmetic series. And if you recall, a series is where you just add up or find the sum of the terms of a sequence. And because every arithmetic sequence is defined by its common difference, and so there's a lot of similarities in these sequences, to find the sum of an arithmetic series, I don't have to use sigma notation. There's a formula, or there's actually two formulas here, that we can use instead. So we're going to do a couple examples here, but the first thing that you'll want to do is write down these two formulas. If I want to find the sum of, let's say, 100 terms, then I would use 100 as the end value, and for this first formula, I need to know the first and the last term. If you don't want to know the last term, then you can use this second formula. So if you need to, pause the video, copy down these two formulas, but this is for the sum of a finite sequence. All right, you can't do it for an infinite number of terms because an arithmetic sequence is either going to go to infinity or negative infinity if you keep adding or subtracting on forever. So this only works for 100 terms, 1,000 terms, 10,000 terms. It's got to stop at some point. So keep that in mind. It does not, an arithmetic sequence or series does not converge. It's divergent. So number one says, find the sum of the first 100 terms if I go 1 plus 2 plus 3 plus 4 plus 5 plus ... 97 plus 98 plus 99 plus 100. And if we were in school, in class right now, I'd actually have you do this on your own and see if you could come up with different ways to answer it more efficiently than just typing all of this into your calculator. But mathematicians have figured out this first one, this formula right here, works out really well. So if I want to find the first 100 terms and add them together, all right, I'm going to take the end value, which is 100, and I'm going to divide it by 2. And then I'm going to take the first term, and I'm just going to add the last term to it. So all this is 50 times 101, and that is 5,050. If you want to know a little bit more about who kind of came up with this and a little bit of a background behind this particular problem, Gauss is the mathematician who's credited with this, but I won't worry about getting into that right now. For problem number 2, I want to add up this sequence right here. And so the hard part is, in number 1, they told us that there were exactly 100 terms. But here, I don't know how many terms there are. So before I could use either of these sum formulas at the top, I'm going to have to find the value of n. So I'm going to use the formula from yesterday, or the previous video, to find the n value first. All right, so I'm going to plug in the last term, 317, equals the first term, plus, and then I'm going to keep it as n minus 1, but then I can find the common difference. So if you look carefully here, they're adding 7 every time. So then I'm going to distribute the 7, combine like terms, and so I get 317 is equal to 7n minus 12. Add the 12, divide by 7. N comes out to be 47. So if you need n, you're going to use the formula that we learned previously. So now that I know that it's 47, I'm going to take 47 divided by 2, and then I'm going to multiply the first term plus the last term. And now it's a lot easier because I have that 47. And if you do that, that is 7,332. That is your sum. All right, number 3, I want to find the 28th partial sum of this. So this is the n value, right? They want us to find the sum of the first 28 terms. I know the first term. I can even find the common difference. If you look, they're subtracting 13 each time. But I don't know the last term. So you can find the last term if you really wanted to, because you know the n value is 28. So that would be the formula from yesterday. Or you can use the second formula. It does it all together. So I'm going to do that. So I'm going to find s sub 28 is equal to 28 over 2 times 2 times the first term plus, now n sub 1 would be 27, and then the d value we said was negative 13. So be very careful. Order of operations here, you have to do everything inside the parentheses first, then multiply it by the term out front. So double check this, negative 4,158. Make sure you can get that answer. But this is where the second formula comes into play. I didn't know the 28th term. Like I didn't know this last term. You could find it, but basically it's finding it for you in this different formula. All right, so that's going to lead us here to problem number 4. Problem number 4, once again, you can use either formula here. I don't know really the first term, nor do I know the last term. So I'm going to find the first term, and I'm going to find the last term. The first term would just be plugging in the 6, so that would be 5 times 6 minus 17. And the last one would be plugging in 28, so 5 times 28 minus 17. So just to let you know, the first term is 13, the last term is 123. So really the only thing that I'm missing here is the n value to use this first formula. And so the n value, if you recall, the n value can be found by taking 28 minus 6, but you have to add 1 back to that result. Okay, so 28 minus 6 is 22. Add 1 is 23. So I talked about that rule previously. So then the sum of the first 23 terms is 23 over 2 times 13 plus 123. 1,564. The hard part is remembering this step right here. It wasn't too hard to find the first and the last term, just because I could just plug it into the explicit formula, which they did not give me previously, but finding that n value, very important. All right, to the last page here. We've got 2 word problems. It says that a ceramic tile floor is designed in the shape of a trapezoid, 20 feet wide at the base, and 10 feet wide at the top. So here's my trapezoid. The tiles, 12 inches by 12 inches, are to be placed so that each successive row contains 1 less tile than the row before. How many tiles will be required? Okay, so let's find just like the first row here. So each tile is 12 by 12 inches, so it's a foot by a foot. So if I have 20 feet here, you know, I'm not going to draw this to scale, but hopefully you can see that there would be 20 tiles for the first row at the bottom. So in my sequence, a sub 1 is 20. Now it says they want 1 less tile per row. So the difference, they're subtracting 1. And I want to end with the last row having 10 tiles because it's going to be 10 foot long. And so the question is, how many rows are in between? Okay, so what's really missing here is the n value, right? I know that the first one is going to be 20 tiles, the last one is going to be 10, but I don't really know how many rows it takes to get to that. So there's a couple different ways you can work this out, but I'm going to find that n value first. All right, so I'm going to use the formula from the first day. A sub n is 10. First term is 20, and then the difference is negative 1. So then I'm going to solve for n. Oops, I need an n right there. Oh, and my equal, wow, I messed that up. Okay, just start over. So 10 equals 20 plus negative 1n plus 1. That looks so much better. And so that would be 21 minus 1n, and then it looks like n, if you solve that, should be 11. Now that we know that n is 11, I'm going to find s sub 11. That would be 11 over 2, and this is the sum formula, 20 plus 10. So that should be 165 tiles. There are more ways to figure out that answer, but that's in the same process that we saw in the front. And number 6, Carter has been collecting baseball cards since his father gave him a 20-card collection. So he started off with his father giving him 20 cards. During each month, Carter's father gives him 5 more cards than the previous month. So we are adding 5 cards each time. And how many months will Carter reach 1,000 cards? So this is a little bit different. The sum of the cards is 1,000. So I'm actually going to have to use the second formula because I don't know n, and I don't know a sub n. Like, I know the sum is 1,000, but I don't know like the last amount that he received right before his total was 1,000. So this is the total. So the last formula from the front is S sub n is equal to n over 2 times 2 times the first term plus n minus 1 times d. So I'm going to use this one instead. I know it's going to be 1,000 is equal to n over 2 times 2 times 20 plus n minus 1 times 5. Oof. So I'm going to clean this up a little bit. 1,000 is equal to n over 2 times 40 plus 5n minus 5. And then that would be 1,000 equals n over 2 times 5n plus 35. You know what? Let's get rid of that 2. Let's multiply both sides by 2. So this would be 2,000 is equal to n times 5n plus 35. So the 2 would have canceled here and here, and then I multiply this side by 2. And then I have to distribute the n. So 5n squared plus 35n. I need to subtract the 2,000 over, and I have a quadratic. I have a GCF of 5, so this would be n squared plus 7n minus 400. And then I could factor this down. N plus minus factors of 400. Oh no, this doesn't factor. There are no factors of 400 that differ by 7. Oh, so I have to use quadratic formula. Man, this is not fun. So negative 7, so opposite B, plus or minus the square root. What am I talking about? This is really fun. 7 squared minus 4 times A times C. Oh, no, I'm going to use a 1 for quadratic formula, so I'm not using this one anymore. I'm going to use this one. So negative 7 plus or minus 7 squared minus 4 times 1 times negative 400 all over 2. All right, so if you do that, right, I'm going to skip all that. I'm running out of room. You would get x to be around 16.8 or negative 23.8. And I'm talking about time here, so I'm going to ignore the negative answer. And if I round 16.8 up, it's going to take about 17 months to get 1,000 cards in total. So this problem would have been a lot better if it had factored, right? I didn't even see that coming until the very end. So if I had been able to factor it, I wouldn't have to worry about quadratic formula. So I don't think you'll see anything that tough, but just note that if it doesn't factor, you can always solve with quadratic formula. And for these word problems, using the decimal might make more sense than a fraction because we are going to round it up anyways in terms of time. There's your video.